Okay, now in this session, the thing what we're going to do is we're going to create ourselves a planetary system, something which can move with all these objects moving around each other. So the first thing that we're gonna do is we're gonna go into our grid and we're gonna create ourselves an out node, and the out node we can just grab directly from here. Let me just clean these things up what we have. So let's rename this to out, because the thing of what we want to do is actually we want to grab these points and we want to simulate these points somewhere else. So what we're going to do now is we're going to lay down a dot network. A dot network is it's actually for dynamics operators network. So here all the simulations such as fire, smoke, liquids, rigid body dynamics, clothing, all these things are being calculated within something like a dot network. So let's go inside this dot network, and the first thing what we're gonna do right over here is we're gonna make sure that we set up our basic structure. Now this is a little bit complex, so I'm just going to explain how to set it up, but I'm not going to go into details immediately. Now even before that, let me just show this tab menu with all the possibilities that you can add. As you can see, like this is this huge list, and we see like several things. We see like the flip fluid solver, and this flip fluids has everything to do with liquids. You have like gas solvers, all kinds of systems for dealing with gases and flames and fire. We've also for geometry and breaking geometry, also all kinds of tools for distorting geometry, whatever you like. So many things, as you can see over here. The thing what we're going to focus on is we're going to focus purely on creating things for SOPs. So if you try to type SOP in the beginning, you see here we see all the things we need. Now we're going to start with creating an empty object. An empty object is something, it's just like a data container, which we're going to give a name right now. And so we're going to call all these things like planets. Now we don't see anything here yet, so for that we need to add some geometry. So now here we can do it again. Press SOP, and here you find SOP geometry. So here we can generate the data which is necessary to get actually our SOPs. So we will find it over here, and because we named it this way, as you can see, it's really easy to retrieve. So accept, and if we're going to apply the data to our empty object, then we're going to see our points over there, or we should at least. Okay, there might be one thing. This is my frame sitting over here, so if I go back to the first frame, then you start seeing them. So it needs to be evaluated. So make sure that you each time jump to the very first frame. Okay, so now we see our points. The thing what we need right now is also a SOP solver. This is the engine, actually, the thing which is going to calculate SOPs over and over again for each frame. So it's going to retrieve data from the previous one, it's going to apply it and do things like that. And a SOP solver is something which is really useful, it's very powerful. You can change geometry over time doing this. And changing geometry over time is, for example, if you have like a burning match, then you know that the end of the match, which is starting to burn, is slightly going to shrink, turns black and deform. Now with a SOP solver you can just initiate a few of these attributes, and you can slowly make those attributes grow over the geometry while things are going on. Now a SOP solver needs also a SOP network which is going to use to deal with. So again, type SOP, and over here we're going to create a SOP network. So we're going to link it to an external SOP, see the subpath over here, and let's go over here and connect it with the subnet. Make sure that you have like these links visible. So by pressing D, go to the dependency, you see over here the show local dependency links. And so like that we can continue on with this. Okay, so if we go inside over here, we're gonna start by importing, hang on, tab, import, no, that's not what I want, it's import object merge. This was actually not what I was looking for, object merge, and we're going to add a null node, which we're gonna call also out. I'm gonna connect it right over here. So now we've made a connection, and the thing we need to do is we need to make sure that we get like the information we have from above, from the subsolver. Now, how do we get that information? Well, we need to use a stamping function for that, and a stamp string function. Now, it's a little bit complex to see what it really is, but let's go over here to our subsolver, and here they have like an example exactly what you need. So you can just take over here the stamp is, and once we apply this, I can show you what's going on. So we go right in here. We're gonna paste this expression right over here. Of course, this is expecting a string, so make sure that you use backticks at the beginning and at the end. The object name that we've created was planets. So if you go up, we see it over here, planets, that's the name that we're using right now. And we need to set the right location. And so it's the planets that comes in, and the data name is geometry. Now where do we need to retrieve it? We need to go just one level up, just adding a point right over here. And as you can see, now we have this. So geometry is actually the name of the data. So if you go over here and you see the data path, you see data path, this is the full path to the piece of data within the dot network. So this is equivalent to writing this. Alright, make sure that you activate over here the output, so that every time we evaluate this whole thing, that we see the result of that. So what's going to happen is the following. The first frame, we get like our initial information. We're going to do some operation on it, and then it's going back to out. That deformed shape is going in again, the new frame, going out, and so on and so forth. So let's try doing some things. For example, something really easy is adding it like a transform. So if you add a transform, we see over here, press enter and just move it a little bit down and go to out. Then if we go up completely, and let's lock our view over here because we want to see like the whole evaluation on top of this, and go back in. So we see that we have moved it down, and we start pressing play. Then these points continue to move each time this rotation. So you can do it also with a small slight rotation, and oops, it didn't rotate. Is it stored our rotation? No, it's not showing our rotation over here. 0.5, or let's do just a rotation of 2, something like this. So as you can see now, you see these things are accumulating. Now you can change over here the order. Oops. That's not really what I'm expecting. Oh yeah, of course. It's because it's all happening in one node. So if we are going to do like another transform, for example, on top over here, and we do like a rotation of, let's say, 3, and we're gonna calculate y that on top of it. I guess this should work. Let's see. Indeed. So that's how you can quickly and easily create some things. Now let's go a little bit further. Let's go over here by creating a FOBSOP. And in this FOBSOP, what you can do right here is you can take the point position, and let's add a noise over here. Combine it, and we're going to add a noise filter, turbulent noise, and we're going to take the position, of course, as its seed value. Going to make it like a 3-dimensional noise, and now we're going to add the changed position on top of our current position, and we're going to feed it back in. So what's going to happen is we get like positions of a frame, we create like a new position, and then the next frame we're gonna have like the same process over and over again. So let's see what's going to happen with this if we're increasing the number of elements. Let's do it like very busy, and as you can see already, we see the distortion over here. So if I start pressing play, you see these points crawling away using the noise. So each frame we see like this distortion happening. Alright, so let's go out again. Now the thing what we're going to do is we're going to start creating our gravity. So I'm gonna switch this back to, let's say, 10 planets. I'm not going to start with too many. 10 planets, and that should be enough. So if you go over here in our subnet, we can just remove everything what we have right here, and I'm gonna move back to the very first frame. So what we see over here is like a set of planets. Now if we want to have for example just simple gravity, how does that work? Well, it's actually quite simple. The thing what we're going to do is over frame we have, let's say, our point, and to our point we're going to add a vector aligned like this. So the point position plus its vector is going to give you the next frame a point over here. Now if you're just going to add like this vector, then what we're gonna see is that we're just going to have like this linear motion going down all the time. The vector doesn't change, so as you can see, this is like a very linear motion. That's something we shouldn't do. So what we're going to do is we're going to store that vector, and we're going to add the vector with the previous vector. So what's going to happen then is we're not going to set like the velocity, but we're going to set the acceleration actually. So we have over here a point, and then we're going to store it, and we take this vector that we have stored and we add another vector on top of that, so it becomes 2 times as long. And then we do this again. 1, 2, third one added, move the point, 1, 2, 3, 4, 1, 2, 3, 4, 5. And as you can see over here, you get like this nice curvature of acceleration. So this object is falling down with an accelerated speed. Okay, so how are we going to set this up? We're going to take over here a point velocity attribute. Doesn't matter for over here, we're not dealing with particles, we're dealing with tops, and here we're setting up our own simulation. So it starts off with 0, and we're going to add over here a constant value, which is going to be the vector pointing downwards. So 3 floats, and we're gonna name this to gravity. and gravity is negative, something like this. So what we're gonna do is we're gonna take our point velocity, which is at the start nothing. We're gonna add our point velocity to that, and then we're going to write this result. So the next frame we're gonna get like this added result on top of that. And here we can add this velocity to our position and to make our points move down. So if you're gonna look over here a little bit from a distance, I'm gonna add my grid, you'll see, oops, they're falling very fast. Yeah, I'm gonna set over here my time to real time. So let me move this up a little bit because we're dealing with time right now. So here is the playback bar. So right over here, this clock is gonna set it to real time. So if you play, we can see it starts slowly, but it's accelerating. So this is how we set gravity. Okay, so now what do we need to do? We need to try and get like our planets in there. So how to deal with planets? So there are a few things that you need to keep in mind, and that is the following. Let me start by drawing on screen again. So suppose we have like a set of planets right over here, some over here, a cluster of planets right over here, and we're dealing with this planet. The first thing that we need to do is the following, and I'm gonna take a different color over here, green. So we need to get like the direction of this planet over here, direction of the planet over there, direction of the planet over there, same for the other planet, and direction of the planet over there. So we need to get all these vectors. That's the very first important step. Once we have all these vectors together, we're gonna add all these vectors and to calculate like a global direction in which it's going to move. If we're gonna add all these vectors together, we're probably gonna get like this really long one going down there. Now the thing we need to do as well is the following. As you can see, the further planet is, the longer that vector is, and that's not exactly what we want to have, because suppose there is this planet really in the neighborhood and it's kind of a heavy planet, and we want to calculate the vector of that, then what you're gonna get right over here is like this very small vector, and it's barely going to have like any influence at all. It's especially the points which are furthest away which are going to have like most of the influence. So this is again the same thing like we did before. We need to make sure that we invert that value. So we're gonna make sure that instead of the distance towards the planet is going to be a value which is going to grow, is that the gravity is going to increase the closer you get to an object. So this is what we need. Okay, so how are we going to set this up? First thing of all, again we need to use a for loop. We need to deal with all these planets again. So for all these planets, and here we can take like the total point number. And what do we need? We need their point position, because I need the point position of the current planet, and we're going to subtract the planets, the other planets for that. So if we going to look right over here, I'm gonna import the position, and we're gonna take the positions of all the other planets. So why do we need that? Well, we need that in order to calculate the direction of the planet. And how do you do that? It's very easy, but make sure that you really think of that and that you can see what's going on. Blue. Let's say we have like two planets over here, and let's say this is the coordinate system: 0, 5, 10, 5, and so on. 10 is somewhere over there. Okay, so now we have this, and what we need is a vector, a vector in this direction. So this is our start position, and this is going to be our end. So how can we get a vector? So this planet is pulling our start planet. So how can we get a vector in this direction? And so a vector in this direction is not allowed. Okay, how do we do this? Well, it's very simple actually. Think of it. If you have the end minus the start, then you're gonna get a positive value. The end is much bigger if you see it over here. The start is much smaller. If you subtract the start from the end, you get exactly the direction where you're going to. So right over here we're gonna do the same thing. This is over here our start, and this is over here our end position. So right over here we're going to add a subtract node. I'm gonna subtract this minus our start position. So this is going to give us already a set of lines. Now we have to make sure that we're going to combine them all. So the same like we did before is I'm going to start over here with a gravity vector, or I can just move this one over here. And what I'm going to change on this gravity is, because all these planets are going to attract each other, is it's going to be like an empty gravity node. So this is the one that we're going to use to add all that information together. So what we're going to do right now is just very simple. We're adding each vector onto each other in order to get like one vector at the end. So let's do this. So now we have over here in the output node the collection of all these planets together unified into a single vector, and let's directly connect it over here to our point velocity. The reason why I'm doing this right now is just to make sure that we can visualize what's going on. Now as you can see, it's our point velocity. How can we visualize this? We don't find it over here. Well, it's something we can add ourselves. So you see over here you have like this text balloon kind of node, something you can access by pressing D, and there you see you have like custom attributes that you can visualize. Now the way how you want to visualize those are things that you can choose over here. So you can choose this as a new generic display, as a text display option, or as a vector display option. So let's go over here with the vector display. The vector is going to be gravity, and the thing what we're actually trying to build over here is the gravity acceleration. So let's give it this name, gravity accel. The attribute, as you can see, we're writing it in the point velocity. So if you hover over it, you can see what kind of attribute that is. That's really important to give it the proper name. So here it is V. Going to override the color, make it green, and we're going to accept this. Alright, now if you look over here and we're going to activate this gravity, we don't see anything. We still have to move what's going on. So we see the next frame, and here you see like all these vectors. Now they're moving very quickly, and the reason is because we have still some connections over here. Let us disconnect the whole thing, and here we see like the combination of all these gravity vectors added together. Now this is still not okay. We need to add some more things over here, because right now we just have like a set of directions. Like I said, we need to make sure that we're gonna make it so that the points which are closest to each other are going to have the most effect. So we need to multiply actually the length of our vector and use that. We have to multiply the length with our vector with the gravity force. So again, the gravity force is something we calculate over here. We take the length of our vector, so that's the length from each point we see over here, and we do, again, we make like an inverse of that. So add a constant value of 1, and then we're going to divide that constant with that length. And if we now normalize, again this shows how important normalization is. If we normalize these vectors, then we can just easily multiply and we have to reverse this. We can multiply this vector together with its length. So if we're going to add this one right now, this is going to give us much more what we're looking for. So right now we see like all these planets moving towards each other, being attracted to the closest neighbors. Oops, I just made a serious mistake. It's over here, the point number, which is the end value, and that's not correct. We're going to change this to this. And now we get like a correct result, as you can see over here. You see these lines, these points are attracting each other, these points are more attracting each other, these three are attracting each other more, and so on. So the only thing we need to do right now is, you see these vectors are very long, so if you start moving these points, they're gonna move like extremely fast. So let's multiply this with a constant so that we can scale down the amount of gravity effect that we see over here. So this is still very fast. We're also going to divide it by the total number of points. It's just to make sure that no matter how many points we have, the speed of everything is going to remain the same. And so now the only thing we need to do is to hook everything up again, like before. We have our initial point velocity. We're going to add our acceleration to that, and we're going to write that point velocity again. As you can see, it's still going like very fast. It's growing, so they're going like really fast. I still think we need to make this a little bit lower, like set 0.5, something like that. And then we're going to add this result to the positioning. So if we start moving now, you see we have created our gravity system. The planets are moving around, and everything is just working fine right now. So one thing that we still can add right over here, remember that we added mass to those points, and so that mass is something we can use right over here. So what we're going to do is we're going to import something else. We're going not to import only the position, we're also going to import the mass. The mass of our planets, which is not a vector attribute, which is a float attribute, but that we're going to use right over here. So now we're gonna have like elements with different kinds of gravity. So this is just working fine right now. There's also something which is called density, and the density is in principle something we can use in order to make sure that they don't over accelerate, but I'm gonna keep it at what we have right now. And so we can see everything is moving really nicely. Okay, so the only thing we need to do is we need to make sure that what we have right over here is going to work as well for our system in here. Oops. So right now everything is connected to the out node. So I'm going to change this. What we're going to do is I'm going to import the DOP network. So, and if we see, we're gonna fetch the geometry from the DOP network. And how do we do this? Well, first getting our subsolver that we see over here, and now we're getting like these transformations from that. I think the transform input geometry doesn't work. No, we need to fetch it. So if we merge it right now, we're gonna see the following. All these elements moving around, some of them with great density, others with more gravity. And so with like this whole system reacting and changing these gravity fields. Now we can continue on, we can make things better, we can add all kinds of ideas to that. So we have over here these points. We can actually first let's do something else. Let's change over here the direction of our circle. Now if we do this, if we start to rotate what we have over here, then this is going to influence, of course, that result. So as you can see, depending on where they are, we're gonna see it's influencing the field over here. That's because we're really using their height, and that's something we can't do. So what we're going to change over here is that after this DOP import, we're going to use a transform node, and with this transform node we're going to make sure that the scaling is set to 0 over here, so all the planets are nicely on the ground. So this way our representation on the gravity field will be okay. I'm also in the meantime going to increase the number of frames for our simulation, so I'm setting this to 5000, something like that. And so if we start to play this whole thing right now, we're seeing that everything is going to remain just like it should be. Okay, let's add some other things to make it more visible. What we're going to do is we're going to add some extra lines so that we can see their motion. So how can we do this over here? We can go to our DOP import, And right here what I'm going to add is we're going to add some trails. So let's say a trail of 10 or a trail of 20, something like this. In the meantime, I'm also going to switch off this view of the gravity acceleration. So now we have like all these lines. See like this whole reaction. On top of that, I'm going to add some geometry to that. So how do we do this? It's very simple. We're going to group by polygons and we're going to skip every number of points, and if we take the total number of points from our out, number of points of course you need to write down the right expression, then we see like everything is being connected nicely with lines. So this will make it much more beautiful as well. So let's merge these ones as well and see what's going on. And we can continue adding more and more information to that. So what else can we add? Let's say that we add also a line towards the ground. So what we can do over here is we can just merge the X-form result with this and also add these lines. I need to reverse that one, and then we get like lines nicely towards the ground. Something like this. And what else can we add? Perhaps some ground points. Let's add some circles over here. Circles, and those circles, they also have like the same size that we can take over here from our transform. As it explains how it's flat. Right. So like this we've created ourselves a nice visualizer for a planetary system with their gravity and everything on top of that. So as you want, you can start adding like more things, like little colors to all the things, and you can also add, for example, some text. So if you use over here the fonts up, cool thing about the fonts up is, as you can see, you can also add expressions over here, which is going to show you something. So you can take, for example, the velocity or the distance from the center, or all kinds of things like that. So this concludes the whole lecture and shows you what you can do with these planetary systems.